After our tensile and compressive type of numerical, let us go for what is basically shear stress problems or shear stress. You'll understand through this problem. Now, if you look at that particular picture which is given in the problem statement, you'll find that the red color hatch line sheet and blue color hatch line sheet, they are overlap with each other and centrally it is connected with rivet. So this is the simple riveted joint problem. These two sheets are subjected to forces also. The force is shown as with P in the figure. Now, if we try to pull such type of sheets which are riveted, so in the next figure you will find that there is a failure. That failure, if you just look at what is the difference between tensile and shear type of failure, here the force, direction of force and the direction of axis of that rivet is exactly perpendicular, because there is a failure of shear shown in the figure. The axis of that particular rivet is exactly perpendicular to the axis of the direction of the force. So here, if you just look at the area, failure area, that failure area in case of our tensile type of stress, it is perpendicular, but here it is parallel to the force. So that is the difference. Now let us come to the problem statement. A pull of 80 kilonewton is given to the rivet as shown in the figure. If the maximum permissible shear stress in the pin is 80 megapascal, find the diameter D of the rivet. So if you just look at the figure, you will find that there is a diameter D of the rivet and it is going to fail. Now let us take the data. Load is 80 kilonewton, permissible shear stress is 80 megapascal, and what is the diameter D? Shear stress is equal to, again it is a direct shear stress, so there is a same formula, force divided by area. Force is 80 kilonewton and area, now diameter is given, means it is a circular in cross section. So area is equal to pi by 4 d square. Only single rivet is there and it is going to cut down. So this is the direction, and because of the direction the rivet is cut down. Now it is a shear stress, so instead of sigma there is a tau. Tau indicates for the shear stress. Shear stress is equal to force divided by area. Now force is 80 kilonewton, so you just look at that particular, tau is equal to 80 megapascal. Load is equal to 80 into 1000 because it is given in the kilonewton, divided by pi by 4 d square is the area. So again we can mathematically find the diameter D, and diameter D comes out 35.69. So 35.69 we must consider a round off value. So let us consider 40 mm as the diameter of that rivet. In this, if you just look at this particular problem, the diameter D we have find, which is comes out safe as 40 mm. Okay. Now let us go for one more numerical based on the same thing. Now this is the second numerical. So statement is same. A pull of 80 kilonewton is given to the rivet as shown in figure if the maximum permissible shear stress in the pin is 80 Newton per mm square. Find the diameter D of the rivet. So now look at the picture again. There is a force P, there is a rivet, and if you just look at the failure, you will find failure. So what is the difference between first problem and second problem? The difference is very simple. In the first problem, the rivet is going to shear out at a single section. Here the rivet is going to shear out in double section. Why? Because there are 3 plates. Because of the 3 plates, that particular rivet is shear out in 2 sections. So if you just look at the data given, load is 80 kilonewton, permissible shear stress is same 80 megapascal, shear stress is equal to force divided by area. Nothing is going to change, only changes here. Now look at the area. Area becomes double because here same force is subjected to twice failure. So there are two sections that has to fail in this case. So 2 into pi by 4 d square double shear. If you just go for double shear, then there is a tau is equal to force divided by area. 80 into 80 into 1000 divided by 2 into pi by 4 d square. Now let us see how much diameter comes out. The diameter comes out is 25.23. So which is lesser than the previous one because here area becomes double. So diameter is equal to 26 mm. By this way you can understand the shear stress. So with this we know what is tensile stress, we know compressive stress, and we know direct shear stress. So this completes our few numerical based on our first chapter, which is simple fundamental of machine design. Okay, thank you.